Okay, so hi there everyone. We have here our next set of videos in in the decimals. And now we're going to talk about the scientific notation. So numbers which are often very large or very small in quantity can be expressed as decimals and powers of 10, or shall we say decimals with the powers of 10. The way numbers are expressed in this manner is what we call the scientific notation. Okay, so again, very large numbers and very small numbers. We can think of it. We call it scientific notation because usually in science we don't really see numbers as they are when we talk about celestial bodies, the planets, the stars. We There are often very large in numbers, so writing them can be quite tasky. So we find ways to make it to be written shortly, and also microscopic things which are very small in measurement, in height, in weight, which is often not very big in quantity, which are very very small, shall we say, microscopic, shall I say, nanoscopic, um, can be expressed in scientific notation, so that we can we can we can make use, or we can still see it in terms of a number, instead of writing a lot of zeros, which are very not much helpful for us. So we need to get rid of those zero writing. Okay, so all numbers in scientific notation, we will use that, can be expressed in this, or is in the form of this one. Okay, so all numbers in scientific notation is in the form of a times 10 raised to the n. Okay, like I said, decimals with powers of 10. So a times 10 raised to n. Okay, where we say that a is greater than or equal to 1. So a is at least 1, but it is strictly less than 10. So we can, if you want to have the real values of a can be 1.00, okay, 1.00 until only until 9.9999999. Okay, 9.99999. So it cannot be 10. In short, if you want to have a short description of a must be a must be something wherein the ones digit, okay, it must only have a ones digit, no tens digit, which is non-zero. Again, a ones digit which is non-zero and no tens digits. Okay, no tens digit. And we're in n here, the exponent is an integer, where n is an element of an integer, or n is an integer. So again, a is between 1 to 9.999, or it can be between inclusively, okay, 1 until 9.999 times 10 raised to n, where n is an integer. So we will be actually we need to, of course, we need to learn on how to convert a number into a scientific notation. This would be really helpful. Again, for example, a very large number such as celestial bodies, planets, we don't need to write all the figures of that number. If it is very small, we don't need to write a lot of zeros, like 0.0000 something, to represent a microscopic object, but instead we can write that in a very clean manner using scientific notation. So we must know how to convert a number, any decimal number, into a scientific notation. And we will be talking about two cases here. In this video, I will be presenting the first case. The second video, I'll be presenting the second case. To make this clean and simple. So we're going to talk about now, as I've said. Oops. Okay, we're going to talk about now. I'm sorry about that. We're going to talk about the case one right now. Okay, the case one. So this case one is something like this. Okay, so if the non-zero digits, again, if the non-zero digits comes first before the decimal point. Okay, again, there's the non-zero digits. So we define non-zero digits as in, digits which are not zero, obviously. So if the non-zero digits comes first before the decimal point, we must move, okay, move the decimal point going to the left. So I mean left as going here, and in a while, left as in going here, okay, going here, okay. We move the decimal point to the left, and n must be a positive integer. Okay, n must be a positive integer. It depends. N depends on the number of movements we do as we go to the left, where the decimal point is traveling, going to the left. So as an example, let's have this one. We have 2,301.8. So we imagine this, for example, a weight of a very big object. So let's say this is in kilograms. So we want to express this in scientific notation. So how can we do that? Notice this is case one because the non-zero numbers, non-zero digits comes first before the decimal point. So this is case one. So what we will do, we'll move the decimal point up until we satisfy the value of a. Again, scientific notation must be in a form of a times 10 raised to n. And we know the value of a as in a must be at least 1, and it must be strictly less than 10. Okay, so it must be at least 1 but strictly less than 10. So we will, you know, travel or move the decimal place up until we achieve this value. So if we're going to move it going to the left, 1, did we achieve this value? Not yet. It's 230. Let's move another one. Did we achieve the value? Not yet. It's more than 10. And if we move one more, so yeah, we did achieve the value of a. A is 2 point something, which is between 1 and 10. So we write it as this, 2, and then we put the decimal point right there, and then we write the others. You just simply write it as 3018, and then we follow this procedure. Anyways, often there are some rules that tells us that we only need to write the two decimal places after the decimal point. But in this video, to make it clean, let's write everything. Okay, 2.3018 times 10 raised to n. Now, what is n? N talks about the number of steps we did, the number of movements we did from the original starting point going to the new starting point. So how many? How many? Please count with me. We had 1, 2, 3 movements. So we traveled the decimal point 3 place values going to the left. So therefore our n is equal to 3. Okay, so this is the scientific notation of 2,301.8. So we have 2.3018 times 10 raised to 3. Okay, so we express a thousands place into something with a ones digit to make it simple. So you might think that this is quite tasky, but imagine a very big number, trillions, zillions, um, a lot of leons there, and then you only need to write this part here, times 10 raised to something. So this is pretty much very powerful, and yeah, this is scientific notation is used in everywhere in science, in presenting light years and such. Okay, so just take note. Um, if we don't find any decimal point in the given number that we have, okay, okay, if we don't find a decimal point anywhere in the given number, we have to assume, okay, that the decimal point is at the end. Okay, it's at the end of the number. The decimal point is at the end of the number. Okay, say for example, we have this one. Say we have 2,300,000. 2,300,000. So we cannot see any decimal point. Where is the decimal point here, sir? So we need to assume that the decimal point is at the end of the number. So strictly here. Okay, so this is our decimal point for this number. Now, so we want to make this as a scientific notation. So imagine this as a mass of a star. Just imagine. So this is a mass of a star in tons, and we would want to convert it into a smaller number. Okay, a smaller in vision. So we use the scientific notation. So again, we need to achieve the value of a. Let me write it here again. So the A must be at least 1, but strictly less than 10. And we say that in scientific notation, again, we have A times 10 raised to n. Okay, where n is the number of movements, A is should be achieved like this. So let's move the decimal point, go to the left, shall we? So we have, and we will just take note of the number of steps that we had, that we will make. So we have 1, not yet, 2, not yet, 3, not yet, 4, not yet, 5. Now this is 23, and it's still greater than 10. So for the sixth movement, we have achieved the value of A, which is 2.3 something, and this is, um, clearly between 1 and 10, 1 and 9.999 inclusively. So we use that value, 2.3. We don't need to write a lot of zeros here, so we just need to put times 10 raised to how many? So again, recall we have 1, 2, 3, 4, 5, 6. So since we did 6 movements, so our n here, our exponent, will be equal to 6. So we write it as this, 10 raised to 6. Okay, so this is our answer for this example. So if we have 2,300,000, so we can write this very cleanly or properly in scientific notation in a very um, vivid way, 2.3 times 10 raised to 6. Okay, so that's for the case 1 where the non-zero digits comes first before the decimal point. So in case 2, we're going to talk about the opposite. Okay, I hope you learned something from here. Don't forget to hit the like button and subscribe. Okay, thank you very much.